the circle is the most attractive, beautiful, symmetric of all the shapes. There is nothing more enticing. And the reason is because of its wonderful symmetry. It's just made by fixing a particular point in space called the center, and then finding all the points whose distance from that center are the same. Look at that. So it's fantastic. This distance, of course, is called the radius of the circle. And all these points have the property that their distance away from that very center, that epicenter, is in fact the same. It's that radius. So for example, suppose I call the center right here, well, I don't know, it has coordinates. This is some sort of axis here. Maybe I start the axes. I'm going to draw them in invisible ink. Watch this. Okay, so they're the axes. So this has some coordinates. Let's say those coordinates are h, comma k. So that's the coordinates. Those are the coordinates of the center of the circle. Now, what does it mean for a point out here to actually be on that circle? Be the circle. Be the circle. It means at that point, let me just call that point since I don't know what it is, and I want to think of it as a general point, just x comma y. What property must x comma y possess? Well, it must possess the only property that's deemed of it in order to be a member of the circle. And that is that its distance from here to here is that fixed distance, that fixed radius. Let's call that r. So let's let r equal the radius. Okay, well then, can we find a fact out about this x and y just knowing that its distance away from this particular fixed center is equal to the radius? Well, the answer is yes. It's the distance formula. So if I connect these two things, I know that length is r, but I can also compute the distance between those two things using the distance formula, or another way of thinking about it, using the Pythagorean theorem. And if I use the distance formula, what would I see? Well, what I would see is the following. I would see that the distance, in fact, let me sneak this up even a little bit further. I would see that the distance between these 2 points would be the following. Well, the square root of, and now I take the differences here, so I'll take x, subtract off h, so that point on the circle, x part, with the x part of the center. So that would be x minus h, and I square that. That's what the distance formula says to do. And then I add to that the difference in the y values. So that would be y minus k squared. And I take the square root of that whole thing. And that equals, well, what is that length? We know it's the radius, so I call that r. Well, that square root looks a little bit threatening. So if I square both sides, if I square this sides, the radical is going to lift. Guess what, folks? I'm going to sneeze. This is going to be really loud. I'm going to... Excuse me, did you hear that? Wow, that was a, I feel much better now. I feel like, you know, if you sneeze, it's like a whole new beginning. It's like a whole new lease on life. Now, what were we talking about? Oh, yeah, circles, right, okay. So, if I square both sides, then this whole huge radical will actually magically lift, but then I will have an r squared here. So what I see is the following fact. What I would see is the fact that x squared, I'm sorry, x minus h squared, that sneeze really took its toll, plus y minus k squared would actually equal r squared. That's what I would conclude. And you know what? That's precisely the condition, if you think about it, that would guarantee that you're on the circle. Every point on the circle must satisfy that, because every point's distance away from the center is r. Conversely, if you are a point whose distance away from the center is r, then you must be on the circle. So in fact, this is an equation for the circle. It's the circle that's centered. Now, where is it centered? It's not centered at minus h minus k. It's centered at h comma k, and its radius is r. So if we want to figure out the equation for a circle whose radius is r and that's centered at h comma k, then what I do is I see that it must be x minus h all squared plus y minus k all squared equals r squared. Okay, let's take a look at an actual example and see this in action. For example, let's find the equation of the circle. So find the equation of the circle that has radius 5 and centered at the point -2, 3. Well, let's think about how that would go. So the formula for a circle is x minus h squared plus y minus k squared equals r squared. Something that you should memorize and not understand? Absolutely not. It's just the distance. All the points x, y, whose distance away from the point hk is r. I just took squares of both sides to clean off that square root that would be there for the distance formula. So now I just insert all the data. You see, I know the center is -2, 3. That means that this is the value for h, this is the value for k, and this is the value for r. So now if I just insert all that, I'll actually find the equation for this circle. It would be x minus -2, because that's the value for h, and I subtract it, squared, plus y minus k, which in this case is 3 squared, equals the radius, which is 5 squared. And so if I simplify that a little bit, I can see x plus 2 squared plus y minus 3 squared equals 25. And when I see this, by the way, that tells me that I must have a circle. And I can figure out its center, and I can figure out its radius. So as long as you know the center of a circle and its radius, you can always write down a formula for it. And what does it mean to be a formula for a circle? What does it mean to be an equation for a circle? It means that anytime you find a point x, y that satisfies this equation, that point will be on the circle. And conversely, any point on this circle must satisfy this when you take its x value and y value and plug it in. That's what it means to be an equation for a circle. It's all the points that can be found, but now algebraically for a geometric object. And so if you think about it, what does it mean? It means if I go to the point -2, 3, so if I go to the point -2, 3, -2 and 3, so there's the center, and the radius is 5, so how would that look? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I don't think I'll be able to draw this as beautifully as before. But I'm sweeping out a circle. It doesn't even quite make it on the screen. That circle has the equation that's over there. You can see it. And therefore, every point on that circle satisfies that. Okay, now there's a special case. Suppose that center was actually right at the origin. Well, that means, so if the center is at 0, 0, then the formula that I have written over there is actually really easy, because then h is 0 and k is 0, and so then the formula becomes what? It becomes really easy. It just becomes x squared plus y squared equals r squared. And so there's a very special case, in fact, when the circle is centered at the origin, so right at the origin and goes around by a certain radius, the equation of it is very simple. It's just x squared plus y squared equals r squared. Okay, well, next up we'll take a look at some more circle facts and see how we can just look at the formula for a circle and figure out what its radius is and what its center is. I'll see you there.